Alright guys, today we're going to take a look at how to rationalize the denominator of a radical expression. So we are still simplifying radical expressions. We're trying to make them as simple as possible. And one rule when you're dealing with radical expressions is you can't have a radical in the denominator. So all of these examples have radicals in the denominator, and our job is to get rid of them. Okay? So to get rid of them, the way you do it is you take whatever your denominator is. For example, we have the square root of 2. And if I'm trying to rationalize my denominator, what I need to do is multiply both the denominator and the numerator by the denominator. So my denominator here is the square root of 2. This means I'm going to multiply the top and the bottom of this fraction by the square root of 2. When you multiply radicals, all you're going to do is take what you have. At the top I have the square root of 5 times the square root of 2, and I'm just going to put that together. In the bottom, I have the square root of 2 times 2. Okay, so now what we're going to do is put this together. Up top, I have the square root of 10. In the bottom, I have the square root of 4. The square root of 4 is going to become 2, and up top, I can't reduce the square root of 10. So my answer will be the square root of 10 divided by 2. And remember, I can't reduce these and say that this is the square root of 5. I can't reduce the square root of 10 by dividing by 2 because 2 is not in a radical. So technically they're not like terms and I cannot reduce. So what I'm left with is the square root of 10 over 2. In the second example, I have the square root of 2 divided by 3 square roots of 5. So what I'm going to do is I'm going to multiply the top and the bottom of this equation by 3 square roots of 5. When I do this, up top I have 3 times the square root of 2 times 5. And in the bottom, 3 times 3 is 9. And I have the square root of 5 times 5. Okay. Well, 2 times 5 is 10, so I have 3 times the square root of 10 over 9 times the square root of 25. I can't do anything with the numerator. 3 square roots of 10 can't be reduced. But in the denominator, the square root of 25 is 5. And when I multiply 9 times 5, I get 45 in the denominator. Now, because I have 3 in the numerator and 45 in the denominator, and they're both outside of the radical, I can actually reduce. And when I divide both of these by 3, I end up with the square root of 10 over 15. And I can't reduce any further, so this will be my answer. In example 3, I have negative 5 plus the square root of 2 divided by the square root of 10. So again, what I'm going to do is rationalize the denominator by multiplying the numerator and the denominator by the square root of 10. And because I have 2 whole pieces now, I have 2 terms, I have negative 5 and the square root of 2. When I multiply by 10, I'm going to make sure that I put it inside parentheses so that I remember to distribute. So my numerator is going to become negative 5 times the square root of 10 plus the square root of 2 times the square root of 10. Okay, so we put both of those inside one radical. In the bottom of my fraction in the denominator, I have the square root of 10 times 10, which becomes the square root of 100. In the numerator, I have negative 5 times the square root of 10 plus the square root of 20 over the square root of 100, which is 10. Now, before we say we're done, let's look at the square root of 20. 20 can be broken down. 20 becomes 4 times 5, and I can take the square root of 4, which means I need to reduce this. So this is going to become negative 5 square roots of 10 plus the square root of 4 times the square root of 5 over 10. And remember, the square root of 4 is 2. So in the end, I have negative 5 times the square root of 10 plus 2 square roots of 5 over 10. And I cannot reduce negative 5 and 10 because I cannot reduce 2 and 10 in the same way, meaning not everything is divisible by the same number. I could reduce them individually, like I can reduce 5 and 10, and I can reduce 2 and 10, but not by the same number. So this is where my answer is going to be. In example 4, I have 2 plus 4 times the square root of 3 divided by 4 square roots of 2. I'm going to multiply the denominator and the numerator by 4 square roots of 2. Remember, since your denominator has 2 terms, the 2 and the 4 square roots of 3, it needs to be put into parentheses so that you remember to distribute your 4 square roots of 2. So this becomes 2 times 4 is 8, square roots of 2, plus 4 times 4 is 16. The square root of 3 times the square root of 2 becomes the square root of 6. And this is all over 4 times 4 is 16, and then the square root of 2 times 2 becomes the square root of 4. So I can reduce the square root of 4 in the denominator. This is going to become 2. So I will have 8 square roots of 2 plus 16 square roots of 6 over 4 times, or the square root of 4 is 2, and 2 times 16 is 32. Now before we say we're done, if you look at 8, 16, and 32, they're all divisible by 8. So if I take this and I reduce, 8 divided by 8 is 1, so I have the square root of 2, plus 16 divided by 8 is 2, square roots of 6, and in the bottom, 32 divided by 8 is 4. This is as simple as I can make this fraction. Alright guys, that was rationalizing the denominator to simplify radical expressions. Have a great day.